Okay, let's turn to page 22 in your strategy book. So we're going to talk about another strategy, repeated subtraction. Remember that we talk about repeated addition to solve multiplication problems. So division is the opposite operation of multiplication, so we can use repeated subtraction to solve the problem here. So let's read the problem together. There were 180 peppers and they were sold in bundles of 36. How many bundles were there? So what kind of problem do you think they are? I have a print copy here. So, do we know the total? Yes. For division problem, the total is always given to us, which is 180 peppers. And then, do we know number in each group or number of groups? What does the problem say? The problem says they were sold in bundles of 36. So, 36 in each pack, right? So we know number in each group. So we are trying to find out number of groups. Yes. So we know number in each group. So we need to find out number of groups, right? So I have 180 here, and then minus 36, one bundle, and I have 144. Take away another bundle, 100, and then 108. Take away another bundle, 36, and I have 72. Another bundle, 36. So I know that 1, 2, 3, 4, 5 bundles. So my answer is 5 bundles, which is my answer is number of groups. So what kind of problem is this? This is measurement division or grouping division, because we know number in each group, trying to find how many groups of 36 are in my total 180. Okay, so, and then I want you to think about the problem here, 224 divided by 4, the page 23. So oftentimes, based on my experiences, people are relatively feel easier to come up with sharing concept of division. So if I share the problems, like 80%, they're talking about their developing sharing types of problem. So think about that. What kind of problem do you want to write? Do you want to write measurement type of problem or sharing type of problem? So usually measurement type of problem is more challenging, even though we use them a lot in our life, in everyday lives. So, but you can think about what kind of problem you're going to make. Okay? So let's think about it a little bit. What kind of problem can you make? 224 divided by 4. Here's an example here. I have a problem A and B. Problem A says Daniel has 224 marbles. If he wants to organize the marbles into 4 containers equally, how many marbles does he need to put in each container? Problem B, Daniel has 224 marbles. If he wants to organize 4 marbles in each bag, how many bags there will be? So I both used the equation is 224 divided by 4, but it looks like the problem looks a little different. Which one do you think is sharing problem? Which one is a measurement grouping problem? So Daniel has 20 and 24, and I know 4 containers, so I know number of groups, so I can find how many in each container. So this is positive sharing division, and this one is 224, and each bag has 4 in each bag. I want to find out how many bags, how many groups. So this is measurement type of division. Does it make sense? Okay. So this is a positive sharing problem, and this is measurement grouping problem. So this one is group size is unknown, number in each group, and this number of group is unknown. Okay. So then how would you solve the problem? We can solve the problem using base 10 block like we did for our last problem here. So we can solve the base 10 block in here to solve the problem. So I can have 224 and then I have 4 groups. So I can equally distribute them into four groups, right? So 224. I'm gonna show you how you can do it. Okay, so now I want to show you the problem A. Daniel has 224 marbles, and he wants to organize the marbles into 4 containers equally, and how many marbles? This is a sharing problem. We know the number of groups, total 224, and we know number of groups, and we want to figure out how many in each group, right? So we're going to talk about container 1, container 2, container 3, container 4. And I'm going to equally divide this one in here. So it's going to be 50 and 5, 50 and 5, 50 and 5, and I have 1. So each container has 50, 5, and 6. So I can equally divide the marbles. So my answer is 56. Does it make sense? Okay. So you just saw how we solve this problem using base 10 block. And what about the long division? So we all learn how to divide a number using long division. Then how we can do this? I can show you here how we can solve this problem using long division. So 224 divided by 4. So what do we do? What do we do first? We probably learned the cover this number here and think about it. How many times does 4 go into 22? Is it right? So how many times 4 go into 22? It's going to be 5 times. And what do we do next? 4 times 5 is 20, which is 20. And you want to take away and bring down 4 like this. Then we want to find out how many times does 4 go into 24. And 6 times 24. So my answer is 56. Okay? So we solve the problem in 2 ways, using base 10 block and then using long division in here. Then I want you to think about the context in here. So think about the context. My problem is 224 marbles and I want to put it into 4 different bags. That's the first one in here. So think about that context. So I have 224 marbles. This is a unit, marbles. And what does 4 represent if it is the first problem? Problem A. It says equally 4 containers. So this one is going to be containers. So when you think about, as we do is long division, cover this, and how many times does 4 go into 22? Then I want to use the language in using this problem here. How many times 4 containers go into 224 marbles? How does it sound? Is it natural or something weird? It's kind of not natural to me. And actually we are doing 224, but what we do here, we say 4 goes into 22. We don't even say place value in here, right? And this 5 means not 5. This is 50, right? What does this mean here? 20 means. What does this 20 mean in here? This is actually really 20? No, this is not 20. This is 200. Right? So this is 200 actually. It has to be 200. And what does 200 means in here? This means 50 groups of 4. 50 groups of 4 is 200. So in my 200, there are 50 groups of 4 I can find out. Or I can put 50 marbles into 4 containers so far. So I spent 200 here. So I have container 1, 2, 3, 4, and I put 50 each. Right? So, and then I have 200 so far. And I have 24 left over. So I can put 6 more marbles in each container. So I know that each container have 56 marbles. That is my answer. This is what we are doing in here. But when you plug in the context in here, 4 container goes into 224 marbles. I don't think it does make sense to me. It sounds really weird. It's very difficult to think about what does it mean. What we are doing in the division is not clear when I use this context in here. But what about if I use a second problem in here? So the measurement division problem here. The measurement problem says Daniel has 224 marbles. If he wants to organize 4 marbles in each bag, how many bags there will be? The same problem with 224 and 4. The same thing here. Right? Process is the same. So this is what we are doing for division problem. But let's talk about the unit. This is 224 marbles and 4 marbles. Problem B. So that's the problem B here. Same unit here. Then I can say how many groups of 4 marbles can fit into 224 marbles. I think I can do this because I can think about 4 marbles. I want to make a groups of 4 marbles until I use all the marbles, and I want to know how many groups of 4 marbles can I fit into 224 marbles. So I can do it. I can make groups of 4. So I know that this is what? 50 groups of 4 I can make from 224 marbles, and have 24 marbles left over, and I want to make another 6 groups of 4 marbles I can make. So I know that 56 groups of 4 marbles are fitting into 224 marbles. If they have the same unit, makes more sense. Compared to this, 224, how many 4 containers can fit into 224 marbles? I'm not sure. It's not kind of clear to me, but this one, if we have the same unit, marbles and marbles, I think this one is more clear. So if we have sharing problem and you teach this way, it takes lots of practice to process because I don't see any connection with this one and that one. But if we use sharing way, like strategy like this, I can easily see what's going on with this problem. But if we have this one and that one, I just don't know how can I do this. So eventually they need to know the division strategy like this, but conceptually they need to understand what does this actual number means. Otherwise, kids make a lot of mistakes how to solve division problem. So 5 should go above the 10th place. Why is that? Because this 5 represents actually 50, not 5. That means there are 50 groups of 4, I make 200. Right? So if they don't know this kind of process, understanding of the conceptual understanding, they don't have that, they put 5 in any place. They don't know if 5 go above 100 or above 1. It's very confusing because they don't know what's going on with this. If you rely on to solely about the processing here. So that's important to think about the concept to understanding in here. So sharing types of problem, maybe you want to use something concrete or some other kind of thinking about it, then maybe you can process this to algorithm. But so if you want to teach the algorithm purely, then I recommend you to use measurement types of problem, because I can see for measurement, I know that what does it mean. I know that how many times 4 marbles can go into 224 marbles. I can make groups of 4 at a time, and I want to know how many groups of 4 I can make in 224 marbles. So if you want to make a story problem like this, then it's going to make sense more to them than sharing problem. But a lot of people, students, know sharing type as division concept, but if you use this one like this, oftentimes doesn't click because I don't see what's going on in here. Wow. Do you see what I'm talking about? So you need to be very careful whenever you teach division problem, depending on the concept. Some strategies may not make the best sense to them. So we have to think about a supplementary way to show them what it means in here. Okay? So I want you to think about that. And so let's go back to think about the former traditional algorithm in here. I just mentioned here traditional algorithm. So page 24, there's a problem in here. Jessica's bookshelves hold 21 books each. How many shelves will Jessica need if she has 483 books? So this is a typical division problem in here. So this is a B copy. So you have, so in here, what do we know and what we don't know? Do we know the total? Yes, we know the total, which is 483 books. Do we know number of groups or number in each group? We know number in each group, so each bookshelf can hold 21 books. Right? So I know what number in each group, so I want to figure out number of groups. So my equation is 433 books. And each group has 21 books, each bookshelf. And how many bookshelves do I need? So 23 bookshelves I need. Right? So this is measurement types of problem, and I want to use long division processing here. So this is long division process here. So 483 and 21. So I want to figure out how many groups of 21 books can I find out from 483 books? So I want to figure out how many groups of 21 can fit into 483. That's about what I'm trying to find out, right? And usually for traditional algorithm, we are trying to cover this number and then find out how many times 21 goes into 48. 2 times, which is 42 here. And then I subtract 63, and I want to figure out how many groups of 21 can go into 63, and 3 times, and 63. So I know that there are 23. Answer means 23 groups of 21 books I can make from 483 books. Does it make sense? So that's what we are doing. So again, in here, we don't talk about place value. This is not 42. This is what? This is 420. That's what we are trying to figure out, and which means not 2 groups of 21. This is 20 groups of 21. That's what we are trying to do. That's why this 2 is 20 above 10's place, not 2. Right? So if we want to use long division, we have to make sure that we place a value here. What does it mean? This is not 2 times 21. It means 20 groups of 21. So I know that it's going to be 420. And I subtract this, and 63 means 3 groups of 21 makes 63. So I know that there are 23 groups of 21 books. Okay? So this is very important when you teach long division. So you see that a lot of people are kind of struggling about long division process. I know. So we trying to support kids. Is there any way, easier way to support them to teach division problem? And this is yes. That's what we are going to talk about. So have we heard about the friendly long division here? Friendly division or 7 division or partial product method. Your strategy book page 24. So depending on the textbook, some textbook introduce this as friendly division or 7 division or partial product method. So if you want to solely teach the rules and process algorithm, you can use this one here. So I love this one here. The same problem here. 483 divided by 21. So you want to find out how many groups of 21 can go into 483, right? So I don't know how many times, but I think 10 times 200, 10 times 21 is 210. So I know that's going to be 210. So 10 groups of 21, I can think about it. So I use groups of 10, so which is 210. So I have subtract is, so this, and I have 273. So I think I can make another 10 groups of 21 here. So another 210, so I have 63. But I think I want to do repeated subtraction with the one group of 21. This is 21, and subtract 42, 21, one group of 21, 21, and 21, and one group of 21 is 21. This is 0. Do you see what I'm talking about? We use the same concept. You want to figure out how many groups of 21 can fit into 483, but I don't know how many on top of my head, but I think 10 groups of 21 is 210, because anything multiplied 10 is easy. Kids should know at this point. So I know that 210 is smaller than 483, so I know that at least 10 group of 21 I can make out of 483. So I'm going to subtract this and have 273. So looks like this is bigger than 210. So I think I can make another 10 groups of 21. I can make. So I have another 10 groups of 21. So 210. And I have 63. So I can go one group of 21 3 times. So my answer is 10 plus 10 plus 1 plus 1 plus 1. So my answer is 23. Does it make sense? If you solve your problem, I guarantee that you understand better. It's easier than you thought it would be. So same thing in here. I want to have the problem same here. 270 divided by 15 is 18. So I don't know how to do that. So usually we do this way. Let's try not to think about that. We want to focus on the concept in here. So I want to figure out how many groups of 15 can go into 270. But I don't know how many, but I can think about it. 10 groups of 15 is, 10 times 15 is 150. So I think I can at least have 10 groups of 15 for this one here. So I see that 10 groups of 15 is 150. So I have subtract here and I have 120. So I don't think I can make another 10 group of 15 because it's too small. But I think I can think about 6 groups of 15 is 90. I know this. You can use different number too. You can use 60. You can use the other number, totally fine. But I know that 6 groups of 15 is 90. So I want to use this one in here. And then I subtract 90 from 120, so I know that 30. Oh, I know this. I have 2 groups of 15 is going to be 30. So I have 10 groups plus 6 group plus 2. So my answer is 10 plus 6 plus 2 equals 18. So my answer is 18. So that it means 18 groups of 15 is going to be 270. Okay? Does it make sense? Okay, good. So let's do let's practice problem. That's going to be the last one you can do for division. But I can show you the earlier problem here. 224 divided by 4, the marble problem. So we want to do how many times does 4 go into 224, right? I don't know how many times, but I think 20 groups of 4 is going to be 80, so I want to try with that. So I'm going to start from 80, which means 20 groups of 4 I can do. This is 80, because it's smaller than 224. So I'm going to take away, and 4, and 144. And I think I can make another group of 20, because it is 80, so I'm going to make another group of 20 groups of 4, I can make here. It's going to be 4 and 60. Okay, but I don't think I can make another 20 groups of 4 this time. So I can make, but I know that I can make 10 groups of 4. Kids usually start with 10 because anything multiply 10 is easier, just adding 0 at the end. So I'm gonna have 40, which means 10 groups of 4 I can make, and I have 24. And knowing my multiplication fact, I know that this is going to be 6 groups of 4 is going to be 24. So now I want to figure out, remember back to the problem here, how many groups of 4 can fit into 224? That's what I'm trying to find out. So I know that 20 groups of 4 can fit in time. Another 20 groups of 4 can fit into 224, and 10 groups of 24 and 6 groups of 24. So my answer is going to be, adding all together, so 20, 10 plus 6 is 56. So my answer is 56. Right? So it is a little bit more step, like extended formal algorithm. But compared to this, we know that we focus on the concept here. We kind of focus what's going on here. We're trying to find out how many groups of 4 can fit into 224, and 20 group, 10 group, and 6 groups. So kids can follow the process in here, and I know that 56 groups of 4 will make 224. So this is a concept of division too. So we're trying to focus on the concepts to help them to understand what's going on with the dividing a number. Okay? Good. So if you have any question, please let me know. Okay? So this is the practice problem I want you to solve here. 299 divided by 13. 308 divided by 14. So try to use friendly division to solve the problem. So I'm gonna upload the answer key a little later. So please solve the problem first, and then watch the answer key. That's gonna help you to understand. Okay? And before talking about that, I want to talk about, so if we want to make a problem, I encourage you to make a problem, but it's always better to make a measurement type, because that makes sense with long division, friendly division. Okay. Oh, I forgot to mention that. Another reason why they talk about this as a 7 division. Some of the textbook, they draw a line here and looks like 7. So that's why some textbook calls them as 7 division. And then friendly division, 7 division, and partial product method. And once you understand this, it's going to be really easy and convenient. So I got a lot of students saying that, oh, now I think I can do long division. Okay? Because they know what's going on in here. Just not following, multiply, divide, subtract, multiply, divide, subtract, just without knowing the concept. Okay? So, last one is here. Talk about this. So how to teach division. We talk about how to teach multiplication. We talk about how to teach division too. So it's always important to start from the concept. So there are two different concepts of division. That's why division can be more challenging than multiplication. Multiplication is only one. We know the number of group, number in each group, finding out the total. That's always multiplication, but not the division like that. For division, it can be either sharing concept or finding number of group. There are two different concepts itself division has. So they need to understand what division means. So you can use drawing, visuals, or manipulatives. So they can start from the concept, and then it provides important foundation for fraction too. Because when we talk about fraction, we want to talk about this concept too. Okay? So, and then provide the context. See, depending on the context, they mean something different problem here, and unit change, right? So Daniel problem, marble, depending on its sharing or measurement problem, the meaning of the units are changed too. So here, this one is sharing problem. The unit is what? How many marbles, right? So 56 marbles, but this one, how many bags, right? So it is going to be 56 bags. They're a little bit different in here. So context, they need to understand and be careful with the unit and spend a good amount of time on concept with easy numbers. Once they know the concept, that's going to help them to understand the difficult concept, bigger number later. So explain the algorithm process, where it comes from. So whenever you show the algorithm, they need to understand where this number comes from, right? So this is why this is important process in here. So they need to understand what this number mean in here. You want to use long division, they need to understand what does this 20 mean? What does this 5 means and 24 means? They need to know what this each number mean, be able to understand the algorithm process. So explain algorithm process, where it come from, and measurement division, number of group is unknown. It's better with algorithm, and repeated subtraction would make more sense. And partitive division, sharing, is drawing block would make more sense, but they can still use this one in here, but measurement division makes more sense with the algorithm. So you need to be, you are only working on the numbers, that's fine, either way you can do it. Whenever you introduce the different concept, then some makes more sense or less makes sense to the kids. So you have to be very careful whenever you're working with the word problems. Okay? Good. So whenever you are done all the division problem, there are two different problems I want you to solve. And the last thing you need to do for this division chapter unit is that reflection. So I want you to go to reflection, discussion board, answer the following question. So we have been collecting strategies in the strategy book. As a classroom teacher, discuss the following using 2-3 main reasonings. So do you think teaching multiple strategy is important? Yes, or I don't know, why or why not? If you would like to use a strategy book in your classroom, how would you use it? Explain your teaching pedagogy of using the strategy book in your elementary mathematics classrooms. Okay, and then that's gonna be it for the number and operation. Okay, so any questions are welcomed. Please let me know if you have any questions. Okay, thank you for watching this.